Hi folks, welcome to day 37. Today we're going to be going over a concept in 6.1 called compound interest. So, as I've told you a few different times, exponential growth and decay comes into our lives all the time, right? Like currently it's in our lives with COVID-19, right? The coronavirus. The models, or like what you're seeing in terms of graphs for the coronavirus, are all based on exponential growth and decay. Well, another really great application that most of you are probably going to be interested in is actually compound interest, no pun intended. So the thing is, compound interest, this is going to be super applicable to anyone that ever wants to have a credit card, anyone that ever wants to take out a student loan, anyone that wants to take out an auto loan, anyone that wants to take out a home loan or a mortgage, right? So if you ever want to buy a car, a home, your education, if you ever want to have a credit card, right? All of those are dealing with compound interest, and they're going to be utilizing, right? If you're the people that calculate how much you owe or how much you get, those people all use this same formula. So compound interest can be modeled with the formula A equals P times 1 plus R over N to the NT. So you can see that this looks a little bit like what we were working with last week, right? With that 1 plus and that 1 minus. And you can also see, since we have a plus sign here, we know that this is going to be an exponential growth no matter what. All right. So let's go ahead and define some things. So this capital A here, that's your total amount. That's the total amount of whatever you're working with. Typically, since we're working with interest, we're almost always working with a monetary amount, right? An amount of money after a certain number of years. This P is what we call our principal, and that just means that it's the starting amount or the initial amount. All right, that's what you start with, your starting value is that P. All right, that's what we called A before, little a. We have this R here, which just like last time is our interest rate, but typically this is an interest rate annually. All right, and just like last time, we need this as a decimal. All right, then we have this N here in two different places, and N is a new thing for us, and N is the number of times that interest is compounded. All right, and when I say compounded, what that means is how many times interest has been calculated and then added to the total, right? So interest, right, if you rack up a whole bunch of credit card debt, interest is how the bank makes money. They charge you interest on your starting value, on your principal, all right? And usually their interest rates are really high, so you're usually going to get a pretty big decimal. Now, the number of times that interest is actually calculated just depends on the bank, but that's why this is a super useful tool, because it comes into your daily adult life, all right? Because unless you have a lot of family help in terms of I'm talking a lot of family wealth or something, the vast majority of adults have to deal with interest, because we deal with home loans and auto loans and education, right, and credit cards. Those are all very normal, very everyday things in adult lives, all right? And some of you might even have credit cards now, but if nothing else, you probably will have them in the future, and it's good to know basically how to use them wisely, right? And part of how you can think about that is through using compound interest. Now, one of the bad things about compound interest is almost all of the examples are word problems, all right? But don't worry, they're not going to be too intimidating. So you deposit $9,000 into an account that pays 1.46% annual interest. All right. What we're trying to do in this example, all right, what I'm trying to get y'all to do is to write an exponential function to model this scenario if interest is compounded quarterly. Oftentimes, your compounded will be told in things like quarterly, meaning four times a year, right? And at the end of this video, I'll actually write out a list of like the most common keywords you'll hear in like in terms of interest, what they mean. All right, so you deposit $9,000 in an account that has a 1.46% annual interest rate, and it's compounded quarterly. So our first step is to go ahead and start with our formula. So I know I have A equals P times 1 plus R over N to the NT. Now, part of why I do that is because there's lots of letters, and I want to really clearly identify what letters are what. All right, let's go ahead and start with the principal, the initial amount. So if we've deposited $9,000 into an account, the principal or the initial amount that we deposit is $9,000. So our P is $9,000. 1 just stays as 1, but now we can look for our interest rate. Remember that we're going to have to convert this into a decimal, but our interest rate for this account is 1.46%. All right, so I'm going to go ahead and come down here and say, okay, well, 1.46%, in order to get a percent into a number, I have to divide by 100, oops, not 1,000, divide by 100, which is the same thing as moving this decimal 2 places to the right. So that means our R would be 0.0146. All right, so our P is 9,000 so far. Our R is 0.0146. Now we have to figure out that N. Oops, that's not a highlighter. So we have our N here and our N here. All right, and it says write an exponential function if this is being if the interest is being compounded quarterly. So that quarterly is actually what tells us about our N. So if you think about a quarter, right, in order to get to 1 full year, if you were working with quarters, well, then you have 4 quarters in a year. I try and think about this like if this is the part that's tricking you up. Keep in mind that quarterly, you can always apply it to dollars, right? So there's 4 quarters in a dollar. So that means that our N, since it's being compounded quarterly, our N is 4. So we have our N is 4, our R is 0.0146, our principal is that $9,000. All right, so now we're ready to go ahead and rewrite this. So we still have that A because we don't know what that is, but our principal is $9,000. We have 9,000. Remember that anytime you're working with these, you don't have to include those units and stuff, so I'm just going to leave out the $sign. So I have 9,000 times 1 plus R, but remember R is 0.0146, over N, and N is 4, to the NT, so that would be 4T. But I'm not done, right? Because this is not an exponential growth or decay function, and we need it as an exponential growth or decay function. So what we got to do is we got to simplify the stuff inside and then deal with that exponent. All right, so that's part of why I did yesterday's lesson first, is because I wanted y'all to already know how to deal with that 4T rather than trying to teach it in addition to a new formula. All right, let's go ahead and simplify this though. So we have 0.0146 divided by 4, right? So that's the same thing as 0.00365 to the 4T. Now, the number of decimals you're including, I would usually include the first 2 or 3 decimal places that are not zeros. All right, so like here I included that 146 because I had 1.46%. So I already had those important numbers, or in science called sig figs, significant figures. All right. But the number of decimal places, to me, isn't super important. Just know that if you were to have rounded this to 0.003 and then said, oh, well, 3 doesn't round up, and then tried to round it down to 0.000, you won't be getting the correct answer. So while I'm normally not super picky on like rounding, I will say for these problems, it's essential that you are including at least 2, if not 3, decimals that are not 0. I'm going to repeat that again because I know that there are some people that probably are just listening to this in the background, okay? It's really important that when you are deciding how many decimals to include, you are always including at least 2, if not 3, decimals that are not 0. So in this case, we had 3 zeros and then 3 that weren't 0. So then we included those 3 that weren't 0. All right, let's go ahead and finish simplifying this though. So I'm going to go ahead and add that 1 in. So then I have 9,000 times 1.00365 to the 4t. But remember, 4t is the same thing as 4 times t, which means I can actually rewrite a new parenthesis set outside my old parenthesis set. And when I do that, then I can evaluate this 1.00365 to the 4th power. And when I evaluate that, then it simplifies it down. So now, when I do that, I get 9,000 times 1.015 to the t. All right? So there you have it. That's how you rewrite, or that's how you write a compound interest problem. All right, so all you do is identify each of the different pieces, right? You identify what the P is, what the R is, what the N is. And then after you've done that, plug them into your formula, which is what we did here in this green step, and then we just simplify it down, okay? The only other thing that you're going to be asked to do is to evaluate after a certain number of years. So this T that we have up here, that's always in years, okay? And so what we could say is, all right, so we deposited this money. What would happen, right, if we left it in there for like 5 years? So the problem would probably ask something like, what is the total amount accrued after 5 years? So all we do is plug in our 5 for our T. So we get A equals 9,000 times 1.015. But this is telling us that T equals 5, and so instead of a T, I'm going to raise that to the 5th power. And then I follow my PEMDAS, so 1.015 to the 5th power is about 1.077. All right, and that times by 9,000 gets me about $9,695.56-ish. All right, so that's the total amount accrued after 5 years. So that's all you have to do for these problems. So I know that people are intimidated by word problems. I totally understand. I get intimidated too, right? Especially like when I was learning them. But all you have to do in a word problem for compound interest is identify your P, your R, and your N. All right, plug them into your formula like we did here. Simplify it down, and then your final step will be when it asks you to evaluate at a given value of T. All right? So that's all I have in regards to the actual notes. However, there are some keywords that you might want to be in tune with for the compounded piece. All right, so you might see things like compounded quarterly. And if something's compounded quarterly, that means the N is 4. If it's compounded monthly, well, that means it's compounded each month. And since N is the number of times it's compounded a year, there's 12 months in a year, so N is 12. All right. Compounded yearly means that it's compounded once a year, so N is 1. Compounded daily would be 365 days a year, so n is 365. All right, so those sort of things, if you come across one that I haven't used here, that's okay. You can figure it out, all right? And this is also like some vocab and stuff, so you can feel free to Google it if you need to. I will make sure that I define explicitly for you. If we're not using quarterly, monthly, or yearly on the test, I will 100% make sure that it is very clearly defined what n is for you there. All right? So that's all I got for you today. Make sure you're trying out your problems in your notes, all right? Or it doesn't have to be in your notebook, but make sure you're trying out those problems from your assignment. Just 2 of them today, since they are word problems. I wanted to give you a little bit of slack. Remember that if you're watching this from a different class, you are following whatever your guidelines are from your teacher. Thanks for watching.